In this video, we're going to start looking at solutions now in solubility. And so we're just going to start with some terminology. In a solution, the main component of your solution is called the solvent. The minor component is the solute. And the reason why you form solutions at all is all due to intermolecular forces. Basically, the solute will interact with the solvent and it'll dissolve because of that interaction, right? So let's look at solutions in terms of mixtures. And so some more terminology. A mixture is just simply two or more substances that are combined. And depending on what mixture you're looking at, you're going to have different compositions. And for mixtures, especially when it comes to solution, it looks like it's only one thing, but in reality, it is made out of a lot of things. For example, a homogeneous mixture we think that is homogeneous, but it's actually a solution, is air. Air is made out of a lot of different elements. Seawater, it looks just like water, but we know there's salt in there. And the reason why things mix at all is that mixing is just energetically favorable. It lowers energy to have stuff mixed, and so nature wants to go to low energy. So let's just take a look at spontaneous mixing. So we have two solutions with a partition. Solution 1 is water. Solution 2 is salt water. And so what happens when we remove that partition, spontaneously the salt will spread out so that no matter where you draw a sample of water from, it will have the same concentration of salt. And that is what we may mean by spontaneous mixing. Okay, so let's look at the types of solutions we can have. We can have three different types, which is a gaseous solution, so air, it's just made out of gas. Liquid solution, where your solvent is always liquid, but your solute could be gas, liquid, or solid. And then a solid solution, usually we don't call solid solutions, but technically they are, where both your solvent and your solute are solid. Now, talking a little bit more about solutions. If your solvent is water, a lot of the times we will call that an aqueous solution. So if water is your solvent, it is aqueous solution. Right? Now let's talk about the solute going into your solvent, that is solubility. So if a solute can dissolve in a solvent, it is soluble. Excuse me. It is soluble. So salt is soluble in water, and bromine is soluble in methylene chloride. However, if that substance does not dissolve in another, it is insoluble. For example, oil is insoluble in water. And the solubility depends on two things, really. One, nature's tendency to want things to be mixed, and two, the type of intermolecular attractive forces between the solvent, solute, solvent, solvent, and solute, solute. All right. So let's just look at nature's tendency towards mixing. We already touched on this a little bit, but this term is actually called entropy. And so let's take a look at this. Again, we have a partition with two different gases. We remove the partition, and this gas is equally mixed. And the reason this happens is because systems want to be low energy. They do not want to be high energy. Negative energy is good. If they can get negative energy, the system wants that. Now, forming a solution doesn't always lower the potential energy of the system. So, like I said, when we have two gases in the same container, they will spontaneously mix. Now, they do this even though the interaction between a neon and a neon and argon is basically the same interaction. Remember, for intermolecular forces, noble gases aren't polar, so all they have are dispersion forces. So neon does not care if it's interacting with a neon or argon. So you might be thinking, okay, then why do they mix? They mix because of entropy, this randomness. The more random something is, the lower the energy it is. Things don't like to be ordered. So for this neon and argon, when they're separated like this, they are very ordered. They are segregated. That's very high energy. While when they're mixed, that's low energy. And this measure of chaos is what we call entropy. Right? Another way to put entropy is a measure of energy dispersal in the system. Right? So really, you want your energy spread out as much as possible. And so if each gas is mixed throughout the whole volume of the box, all of the energy is spread out in that box, and so entropy is at a maximum there. You want entropy. You want chaos. Another way to put entropy. If you have 52 cards in a deck of cards that are ordered, you throw them up in the air, they are not going to come down in order. They are going to be spread out because when you throw them up, their energy is going to spread out. Entropy. All right? So let's actually look at intermolecular forces in solutions now. We're going to actually see how solutions form in energy. So what we're talking about is just all the attractive forces that are available. So to mix a solvent and a solute, you have to do two things. You have to overcome two types of energies. One, solute and solute molecules have attractive force amongst themselves. To mix something, you have to break those interactions. The solute. And the solvent also have attractive forces. So to break these interactions, you have to put energy into the system. So that is an endothermic process. And you get some of this energy to break these interactions through the mixing itself. By mixing, you get energy, so that process is exothermic. So let's take a look at this table now. So let's say your solvent and your solute interactions are very favorable, and they're stronger than your solvent, and solute interactions. If the intermolecular forces between your solvent and solute are greater than the pure components, your solution will always form. If the interactions are equal to each other, then your solution will still form because you're getting energy through the mixing. However, if your solvent and solvent want to be with each other, and if your solute and solute want to be with each other, well, your solution may or may not form. It depends. How much energy do you get out of mixing? If you get a lot of energy out of mixing, you will have a solution form. If you do not get a lot of energy out of mixing, like oil and water, the solution will not form. In this ability to make a solution, we call this solubility. So the maximum amount of a solute that you can put in a solvent, that's called the solubility, right? And there's some kind of limit to it, and we have some rules we can follow. If you have two gases, 100% they'll always be soluble. Two liquids that are soluble to each other are miscible. So oil and water can both dissolve in each other, so those are miscible. Oil and water cannot dissolve in each other. They are not soluble with each other, so they are immiscible. And really, solubility depends a lot on temperature. The hotter something is, the hotter your solvent is, the more kinetic energy it has, and so the easier it is to dissolve something. And so when you're asking yourself if a solute will dissolve in a solvent, what you need to keep in mind is this phrase: like dissolves like. So polar dissolves polar, nonpolar dissolves nonpolar, polar will not dissolve nonpolar. So as long as the molecules have the same type of chemistry, they should be soluble with each other. And that's it for this video. I'll see you in the next video.